right, this is going on page 64 when we're done. So the first step in what we do is factor. Yeah, make sure you're looking at the right one. I had the wrong thing up here. Is factor. This is already factored. That's good, right? So are there any holes here? No. And how do I decide that? If you can cancel anything out. I can't cancel anything out, therefore there is no point discontinuity. So this is none. My roots come from where? The numerator, right? So I've got 2, I've got 0, or I've got negative 2 and 0. Then the vertical asymptotes come from the denominator, so I get x equals what? Negative 6, and x equals 3. Is there any tangency or togetherness? Yes. Which one? Both, right? There's both. So tangency comes from the numerator. Togetherness comes from the denominator, right? So the tangency, so I do have both, but I need to make sure I notate them correctly. So I have tangency at x equals 0, because that's the 0 in the numerator, right? And then I have togetherness at x equals what? 3. Very good. Okay, everybody good with that so far? Then, do I have a horizontal asymptote? What's the degree of the numerator? It's tied. The degree of the numerator is 3. The degree of the denominator is 3. So it's tied, which means I do have a horizontal asymptote. It is y equals 1. Good. It's the ratio of the leading coefficients. In this case, is just 1, which means there is no slant asymptote, so that's a none. Y-intercept, when it's factored out, that actually means I have to do at least a little bit of something. But once I substitute 0 in for x, what do I get? Like 0 automatically. Once I substitute this 0 in right here, that zeroes out the numerator, which means it doesn't matter what else happens, it's 0, 0. Okay. So then I need to do my number line and come down here. I need to rewrite this so that I can see it. F of x is equal to x squared times x plus 2 over x minus 3 squared times x plus 6. Okay. All right, so then on my number line, I put my zeros and my vertical asymptotes. So that means I start out here with negative 6, and then I have a negative 2, then I have a 0, and then I have a 3. So when I substitute this in to test, if I substitute in like a negative 7, and I put it in here, what's the sign going to be? Positive. Is it possible for me to substitute any real number in here and get a negative? No. So that right there is going to be positive no matter what. What happens when I substitute in right here? Positive no matter what again, right? So since these two things are always positive no matter what I substitute in, do I even need to worry about them? No, because the positive doesn't change the sign. The two things that are driving the sign here are these two, and that's really the only two I need to pay attention to. So if I substitute in the negative 7 here, that's going to give me negative over negative, which is positive. If I substitute in a negative 3, that's going to give me negative over positive, which is negative. If I substitute in a negative 1, that's going to give me positive, positive, which is positive. If I substitute in 1, it's going to be positive, positive, which is positive. 4 will give me positive, positive, which is positive. Now, a lot of what we have had has alternated, right? This doesn't alternate because they don't alternate every single time. That's why you have to check them. So this is positive, negative, positive, positive, positive. So let's think about what's really happening here. At negative 6, I have a vertical asymptote, right? My function is going to have to hug that side of it, and then since it's negative, it's going to look like that on either side of that asymptote. Does that make sense? At negative 2, I have a 0. So this is where it passes through the x-axis and becomes positive. At 0, I have another 0. But what's happening at x equals 0? It's bouncing. It's tangency. So this is where your bounce comes from. So it was positive and it stays positive. Does that make sense? Then at 3, I have another vertical asymptote. But what special is happening there? It's togetherness, which means that my function looks like this, and they're both going on the same direction on either side of the asymptote. So this is, the sign chart tells me a lot about my graph. When you're struggling with what the heck is it supposed to look like, this is what you need to refer to. Okay, and this is what, if you just completely ignore it, it's going to get real confusing over there. Okay. Tangency is going to, like, here's the axis. Instead of passing through it as 0 like this, it bounces, so it's tangent. It only intersects it at that one point right there. Okay, your tangency is your bounce, like we had. Okay, anything else? All right, let's graph everything we can graph on here. Then I've got no point discontinuity. I have roots at -2 and at 0. I have vertical asymptote at -6 and 3. And then I have tangency and togetherness, which we'll come back to. I have a horizontal asymptote at y equals 1. And I have a y-intercept at 0, which I really already took care of, right? Okay. Huh? All right, so that's all I got right now. So I've got 3 sections of my graph. I've got something happening on this side of the vertical asymptote. I've got something happening in between the 2 vertical asymptotes. And then I've got something else happening on this side. The problem with the 2 outside pieces is I don't have any points out there at all. Okay, but I can plug it in. But let's focus on the middle first, since I do have some points there. And let's see if we think we need any more points. So that may be enough points for me to get what's going on here. If I look at my sign chart, from -6 to -2, my function is negative, right? And I already know that it's got to look something like that, right? Then from -2 to 0, my function is positive, right? So this comes up here to the positive side. Then at 0, it bounces. And then from 0 to 3, it stays positive, so it's got to go up like this. So do I really need any more points? I mean, a couple points might be able to get certain things more accurate, but if I know I'm supposed to be negative from -6 to -2, it has to come up and look like this. Like there's really no other option. Then from -2 to 0, it's positive. I don't necessarily know how far it comes up, but that's okay. This is still semi a sketch. But then when it hits 0, it bounces, and then it's going to stay positive, so it has to come up here. And then that is what that middle piece looks like. And remember, in between 2 vertical asymptotes, it's either going to look, it's going to have end behavior like a quadratic, or it's going to have end behavior like a cubic. And in this case, it's got that cubic look to it. Okay, we good with that? Any questions at this point? All right, so now let's look at this section over here. On this side of this, x equals -6. So we're going to substitute in some points. You don't have to substitute in 30 points. Like 1 point in each section might be enough. So we'll try -7, right? It's just right on the other side of it. So when I substitute in -7 right here, I'm going to erase my little picture so I have more room to write. All right, so when I substitute in -7, this is going to be -7 squared times -7 plus 2 is -5 over, that's going to be -7 minus 3, which is -10 squared, times -7 plus 6 is -1. Everybody with me on that? So what's -7 squared? 49, right? So I have 49. And then let's think about this too before I go any farther. In the end, is this number going to be positive or negative? It's going to be positive. You know why? I know a couple of reasons why. Because of this, and also these two have to be positive, and then that's negative over negative. So at this point, I can just ignore all the signs. Will you agree with that? So then this is going to be 49 times 5. And then in the denominator, what is 10 squared? That's 100. And then times 1, I can just ignore that. I don't care what 49 times 5 is. Like, sure, I can multiply that out. Totally pointless. So don't jump in and just start multiplying for the sake of multiplying. You can reduce here. 5 goes into 5 once. It goes into 100 20 times. So what you end up with is 49 over 20, which I know you still don't like, but it's okay, right? Because in the end, I know that the whole thing's going to be positive. If I can make that decision now, I'm just going to ignore them so I don't do something weird. That's a good question, though. So his question was, how did it magically turn? It's not technically magic. It was just that since I knew that, that's why you want to look at it before you just start doing stuff, because sign errors, they're so easy to make because they can mess your day up real quick. So I get 49 over 20. All right, how many times does 20 go into 49? 2. So I get 2 and 9/20. 9/20 is about a half, right? So 2 1/2 is a good enough estimation here. So I can go to -7 and 1 2 1/2. And do you think that that 1 point is probably enough to get the shape I need? Yes, I think that would be absolutely fine. And it's going to look like this. Okay. Everybody good with that? So then I will substitute in right on the other side of this one, and we'll substitute in a +4. When I do that, I'll get 4 squared times 6 over 1 squared times 10. Yes? Yeah. So then this gives me 16 times 6 over 10. So I'm going to reduce before I multiply anything out. I can divide these both by 2, so this becomes 5 and this becomes 8. So what's 8 times 6? 48. So I get 48 over 5. Okay. So how many times does 5 go into 48? 9 with 3 left over. So I go to 4, and then I go up to 9 3/5. And does that really help you any? No, because I pretty much knew that's where it was starting anyway. So I could jump to 5, but I think I'll go ahead and try 6, so I don't have to keep doing a bazillion other points. When I substitute 6 in, I get 6 squared, right, times 6 plus 2 is 8, over 6 minus 3, so this is 3 squared, times 12. Okay, so watch this magic here. 36 times 8 over 3 squared times 12, leaving like that. All I did so far was square the 6, okay? So the 12 goes into 36 3 times. Do you agree with that? And then this is 3 squared, so I can cancel this 3 out with one of them, and I'm just left with 8 over 3, and I really didn't multiply anything. And if you can learn how to manipulate your numbers like that, they can really, really help you. Or you can multiply it all out and get ginormous numbers and then have to reduce them, but whatever, okay? Did I lose you somewhere? No? Where'd the 2 go? This 2? Because I had a 3 up here, and this is 3 times 3, so basically they just took away one of those 3s right there. All right, so I get 8/3. So that's 2 and what? 2 and 2/3, yes? So I go to 1, 2, 3, 4, 5, 6, and I go to 1, 2, and 2/3. It's right about there. I think those 2 points are probably good enough to get me that. Okay. So going into that, had no idea. Even I had no idea. I know you probably think, oh, she knew exactly what it was going to look like. I did today because I've done this problem before. But like the first time I did it, I had no clue what it was supposed to look like. So I had to use my chart and everything else just like what I showed. If I go back, I'm not going to remember that that's what this one looked like because the equations can look very similar to each other. Everybody good? Don't be afraid of them because there's a lot going on. Just make sure you understand what's going on with this chart. Okay? Anybody got any questions? All right. That was a lot, I know. Let's look at number 6. So it's factored again. That's nice. Sometimes that's nice. Sometimes it's not so nice. So do I have any point discontinuity? No. So there's none here. My zeros, it's going to be -2 and 3. Vertical asymptotes, x equals -1 and x equals 2. Y'all got this down, right? Like this is no big deal here, I hope. And then, is there any tangency or togetherness? Togetherness? Tangency. Numerator is tangency. So there is tangency at x equals -2. Do I have a horizontal asymptote? It's top heavy, right? It's a degree 3 over degree 2, so that's no. I have instead, excuse me, I have a slant asymptote. In order to figure out what my slant asymptote is, what do I have to do? I have to multiply it all out, and then so I have to divide, but I'm going to have to multiply before I divide. In the interest of time, I'm just going to multiply this out for you, but this is the process you want to go through. This is going to be x minus 3. Now, this is a perfect square trinomial. Remember, if you actually know what to do with that, that can be helpful. This is x squared, and then you multiply these two together, which is 2x, and you double it, plus 4x, and then you square this, and you get plus 4. If you don't know those steps, if you FOIL it or whatever, that's fine, but you need to get rid of the whole box method if you're still doing that. In the denominator, you're going to get x squared minus x minus 2. Then in the numerator, you're going to need to distribute this and combine your like terms and whatnot. What you end up with is x cubed plus x squared minus 8x minus 12 over x squared minus x minus 2. Okay. So as much as you don't like factoring, I actually think you like it and multiplying it back out. But maybe I'm wrong about that. So now that I have this, can I use synthetic division? No. And I don't know, you right here, you may not have a ton of room, but I think you have more room up above this than I do. I need to do long division, but the nice thing is you don't have to do it all the way because you don't care about your remainder anyway. So x cubed plus x squared minus 8x minus 12. So this looks horrible. It's really not that bad at all. X squared divides into x cubed, and what do you get? X. So you make sure you put it over the x term. Then you multiply it back. X times x squared is x cubed. X times negative x is negative x squared. X times negative 2 is minus x. Now remember this for long division. You have to change the signs. So this becomes minus plus plus. So this gives me 2x squared minus 6x minus 12. X squared divides into 2x squared a positive 2 times. Guess what? The rest doesn't matter. Because once I multiply this back together and subtract, I'm going to have something else that's my remainder. Do I care about my remainder? No. So once you get a line up here and you're done, you don't even have to multiply. You're done. It's not, you don't have to do the whole thing. And then that's your slant asymptote, and so that is a y equals x plus 2. And there was none for the horizontal asymptote. All right, so now we had to multiply it all out, but that actually helps us with our y-intercept. What's the y-intercept? 0 what? Remember how to look at it? It should be real easy. Okay, so all this zeros out. You got negative 12 over negative 2, and that is 6, positive 6. All right, so before we do anything else, we go look at our sign chart. Our number line sign chart, same thing. I'm going to rewrite this. F of x equals x minus 3 times x plus 2 squared over x minus 2 times x plus 1. So on here, I have to put negative 2, negative 1, 2, and 3. So over here, when I substitute this in, negative 3. Negative 3 in here is going to give me negative. Now, since this is squared, it's always going to be positive, right? And I can ignore it, yes? And so then the denominator would be negative and negative. So overall, that's negative. If I put in a negative 1.5, it's going to give me negative, negative, negative. Overall, that's negative. Between negative 1 and 2 is 0, so that'll be negative, negative, positive. Between 2 and 3, I can do like 2.5, so it'll be negative, positive, positive. And then if I do 4, positive, positive, positive. Okay, everybody good with all that? So this is negative, positive, negative, positive. All right, so let's graph what we know here. I have zeros at negative 2 and at 3. Vertical asymptote at negative 1 and at 2. I have tangency, which we'll get back to, I have a slant asymptote at y equals x plus 2. So I go to a positive 2 on the y-axis. My slope is 1, so I can go diagonally through my little squares. And then I have a y-intercept at 0, 6. All right, so that's all of my pieces. So is there anything that you find a little strange at the moment? Yeah, there's a point on the asymptote. Now, did we learn yesterday, though, that we can cross some asymptotes, right? Which ones can we never cross? Vertical. Vertical ones you're never going to cross. Horizontal and slant, it is possible. You do not know by looking at the equation to begin with. You either find out because it clearly just happens, or you have to test it. And we did test some of them. We're not going to test this one because it gets kind of yucky with the slant asymptotes. You'll just have to take my word for it. So here's what we know. We know that from negative infinity to negative 2, right here, my graph is all negative. So it's coming from down here, but it's on the asymptote. So I don't know if it's coming from underneath here or if it's coming from on top of the asymptote. I don't know that yet. Then between negative 2 and negative 1, it's also negative, which makes sense because what else do I have at negative 2? I have what? What does it say? Tangency. So it's negative, it comes up here, it's going to bounce and come back down, right? And then from negative 1 to 2, everything is positive, right? So is this going to have a look of cubic or a quadratic? Quadratic. If it's all positive, it's all got to be up here, right? And then between 2 and 3, it's negative, so it's coming from down here, which makes sense. And then from 3 to infinity, it's positive, so it's going to keep coming like this. So I think that this part of the graph, we could probably just go ahead and sketch that part in. It's got to look something like that. Okay. So let's go back to this side over here. So I'm going to tell you what I know because of the algebra that I did that wasn't real pretty. There is tangency here. This only crosses the asymptote once, which means it only crosses it here. But still, two things could happen. It could come up here, and it could bounce, and it could hug this side of the asymptote. Actually, it would make it have to come back, so it's really, that's not a possibility. Or it could come up, and it could bounce and come on this side of it. And this is what actually happens. You would have to test to see how many times it crosses, and then also just like test a point over here. But I'm not going to make you do that, and you're not going to come up with another one like this. So it looks like this. It bounces, and then it's got to stay close to this asymptote over here. Remember, when you cross one, you don't get to just kind of go off into Never Never Land. It's still going to come closer and closer to that asymptote, so it looks something like that. Now this middle piece, I know it's not going to cross my asymptote, even though I know it's supposed to stay up here. It's not going to drop all the way down here because I already tested it, and it's not going to cross more than once. I know it has the look of a parabola. That one point might be enough, but we're going to go ahead and try x equals 1 and see what happens. So once I substitute in 1, that's going to give me negative 3 times 3 squared over 1. Gives me negative 1 times 2, right? Oh, what did I, that's not negative 2. It's negative 3. It's negative 2. Because when I substitute in 1 minus 3 is negative 2. Isn't the denominator negative 2? Once you multiply that out? Doesn't that cancel out with that then? What's 3 squared? 9. So at 1, you're at 1, 2, 3, 4, 5, 6, 7, 8, 9 right here. So that's another point. So it looks something like this here then. I don't know necessarily that my y-intercept is the minimum, but that's what we're going to go with right now because it's the best we can do. Okay, we good? Questions? All right. Look at number 7. So number 7. Need to factor the rest of it. So this is going to give me x minus 4 times x plus 3 times x minus 1 over x plus 2 times x minus 2. Okay? Any holes? Nope. How many roots am I going to have? 3. So I have -3, 1, and 4. I have 2 vertical asymptotes, x equals -2 and x equals 2. Any tangency or togetherness? Nope. That is none. Do I have a horizontal asymptote? Nope, because it is top heavy, right? So I'm going to have a slant asymptote. So it was sort of multiplied together, and then I took it apart. So when I multiply it all back, I'm just going to give you what it'll be. X cubed minus 2x squared minus 11x plus 12 over x squared minus 4. Then I need to do long division again. So x squared minus 4 is going to divide into x cubed minus 2x squared minus 11x plus 12. Yes? All right, so x squared divides into x cubed, and I get x, right? So I put it right there. X times x squared is x cubed. X times a -4 is -4x. It goes way over there. I change my signs. This comes down as -2x squared minus 7x plus 12. X squared divides into this and goes -2 times. Then I'm done. I don't have to multiply it back out. I don't care because it's going to give me a remainder that doesn't interest me at all. So this is just y equals x minus 2. If it's in here, you absolutely have to put it. In here, if you understand that it's there and you don't put it, it's okay. If you feel like you need to put it or you're going to do something weird there, then I would suggest that you put it. But you just have to make sure that you're putting that underneath the correct thing, and then you're okay. Do not leave it out if it's up here, though. That's a good question. All right, my y-intercept, which is actually easier to find looking at this form, right, is going to be 0 what? 0, -3. Now, my sign chart for my number line. This is f of x equals x plus 3 times x minus 4 times x minus 1 over x plus 2 times x minus 2. All right, so on here I have to put -3, -2, 1, 2, and 4. So let's test the first one. Put in my -4. Give me negative, 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 negative. So overall that is negative. Let's just pause there for a second. Sometimes when we do these, they just straight up alternate. And sometimes they don't. So when do they not alternate? When there's tangency or even togetherness. So if there's tangency or togetherness, so let's pretend like there's an asymptote at -3 and we have togetherness. That would mean that this is negative and negative because they'd both be coming this way, right? Or maybe there's tangency and then it's going to bounce. If I do not have any tangency or togetherness, which I don't here, then it completely alternates. I have to check the first one, and it's still important to me over here. But if this first one's negative and there is no tangency or togetherness, they alternate, and you don't have to test the rest of them. Now, I'm telling you that with some reservations because I'm afraid you're just going to always think they alternate. If you have tangency or togetherness, you probably still want to check them, okay? But if it doesn't, there's no need to test. There's a lot of numbers in there, right? And you're capable of it, but if you don't need to, it's okay. Oh, that's fine too. Yeah, it can start. I know they all seem to start with negative first as well, but it could start with positive. It would still alternate. Okay? And if this was the place you had your tangency and it was like negative, negative, and then it would alternate after that. Okay, you could once you have an understanding of that, maybe you can get all that figured out. Just be careful with it because if you mess this up, it's going to really confuse your graph. So it looks like this because that's still important for us when we graph. All right, so I've got -3, 1, 2, 3, and 4. And then I have an asymptote at -2. And 1 at 2, and 0, -3 is my y-intercept. My slant asymptote, y equals -2. So get all that drawn in. Okay, so from negative infinity to negative 3, all this is negative, right? So here's my asymptote. It's going to come up like this. Then from negative 3 to negative 2, it's positive, and I have that asymptote there. So this is what it's going to look like. I have that 1 point. That's enough to get me that. Okay? Then from negative 2 to 2, or I'm sorry, from negative 2 to 1, my graph is negative. Because see how these alternate? Since I don't have any togetherness, I know it has to come up here. So it's negative till it gets to 1, and then it's positive between 1 and 2, which means the middle part here in between the two vertical asymptotes does not look like a quadratic. What's it going to look like? A cubic. And you have to have that point of inflection there, because if you don't, you see how if this was just a line, it's going to poke through that asymptote? And that's a big fat no-no. So when it comes down like this, it has to have a point. Oh, sorry. I can't do it when I'm standing sideways because it's going to come down here, and then even that can be your point of inflection right there. We don't know exactly where it is, and that's okay. But do you see how I kind of have to have one so it can hug the asymptotes on either side? Then from 2 to 4, it's negative. So here's an asymptote, so it's going to come up like this. And then from 4 to infinity, it's positive. So again, that just looks like this. I didn't have to test any points. I didn't have to do anything. Good on that? Yeah? All right. So we got one more to do, and I want y'all to hang in there with me. And I feel like I've been talking too much with these because that's why we haven't had time for that quiz. So I'm going to, for this 6 weeks, because today's the end of the 6 weeks, I'm going to go in and I'm going to put 100 in for that quiz, but I'm going to give it to you, and you're going to take it home this weekend, and you're going to turn it into me on Monday as a take-home quiz. My grades will be due by then. If you don't get that thing turned into me on Monday, I'm going to go back and change that grade and put in a 0. You got it? Okay? It's going to be 100 no matter what, as long as you turn it in, and not just chicken scratch made up numbers either. I'm not a moron. I mean, like, you have to make some effort on it. Let me be clear on that. But because you need to know how to do it. I want you to be able to do it. But I also, this is important to me too. You need to see this, even though I know we've been graphing a lot. So we got one more. All right. So is this completely factored? No, almost, right? Like almost. But I can factor out that 3, which will actually help me if I factor it out. So 3 times x minus 1 times x plus 4 over x plus 2 squared. All right. So once again, no point discontinuity. I think like yesterday, all of them had it, and today none of them do. So it just depends on the graph. I have 2 roots, which would be negative 4 and 1. Vertical asymptote, x equals negative 2. Do I have any tangency or togetherness? Togetherness. So I have togetherness at x equals negative 2. Do I have a horizontal asymptote? Yes, thankfully. We don't have to do long division, right? So they are tied in degree. That means I have a horizontal asymptote, and it would be y equals what? 3, because it is the ratio of the leading coefficients. And if I multiplied all that out, there'd be a 3 on the top and a 1 on the bottom. So good. Which means there's none of these. My y-intercept, now since it's not multiplied out, I have to actually do a little work, but it's not that big of a deal. I just have to substitute in 0. So 3 times negative 1 times 4 over 2 squared. What's 2 squared? 4. So those just cancel out, and I just get negative 3. Everybody good? Okay. So now let's look at our number line. We have f of x equals 3 times x minus 1 times x plus 4 over x plus 2 squared. Now this 3 we get to ignore. Since it's positive, it doesn't even do anything for me. So on here I put negative 4, negative 2, and 1. So I test my first one, right? I'm going to substitute in a negative 5. It's going to be negative, negative. The denominator is positive no matter what, right? So this actually is one that starts with a positive, finally. Then let's think about this. Do I have any tangency or togetherness? Yes, I have, what was it, togetherness? That means I have an asymptote here. Here's where my togetherness is, right? So the signs on either side of that asymptote are the same. Otherwise, it alternates. So if this is positive, this is negative. What's this have to be? Negative, and this has to be positive. You always have to start off with 1 no matter what, or you don't know where to start. Does that make sense to you? And you can stop with all the sign stuff as long as you understand how to do it correctly. So your graph looks like this. And this was togetherness, so it's going to look like that right there. And then this is positive. So then we'll graph everything we know. We have roots at -4 and at 1. Vertical asymptote at x equals -2. And that's also where my togetherness is. Horizontal asymptote, y equals 3. Y-intercept, 0, -3. Okay. So here's what I know from my sign chart. From -infinity to -4, it's positive up here, right? -4 to -2, it's negative, which makes sense because I know I have my togetherness here. I'm going to go ahead and put in these branches. And then this is from -2 to 1, it's negative. So I know that these parts, maybe do that, sorry, thrown off by that, looks something like this, right? There's my togetherness. The other ones are going to come up and it stays positive. However, we have this asymptote. And remember, it is possible to cross them. Is this a symmetric graph with this being the line of symmetry here? No. So maybe it crosses it and we need to check and see if it does. So if it does, then this function, it's whenever this function equals the function that is the asymptote, right? So we're going to check that out and see what happens. I'm going to take 3 times x minus 1 times x plus 4 over x plus 2 squared. And I'm going to set it equal to 3 to see if this ever has a y value of 3 to see if it's going to intersect. You with me? So I'm going to multiply both sides by that denominator. So I have 3 times x minus 1 times x plus 4 equals 3 times x plus 2 squared. Notice how I haven't even multiplied anything out yet? Because I don't want to. Because you know what? By not doing that, that just helped me a little bit. Because can I divide both sides by 3? And the 3's go away, right? Boom, they're gone. Otherwise, they'd be all multiplied in there with that mess. Then I would multiply these two together over here, which would give me x squared plus 3x minus 4. And over here, when I square that, I'd get x squared plus 4x plus 4. And then I just solve for x. What happens when I subtract x squared from both sides? They cancel out, right? Those cancel out, so they go away. So that leaves me with 3x minus 4 equals 4x plus 4. So I can subtract 3x from both sides and get x over here. Subtract 4 from both sides and get negative 8 over here. So this tells me x equals negative 8. So is this going to cross the asymptote? Yes. How many times? Once. What happens when x equals negative 8? What does y equal? 3. When x equals negative 8, y equals 3. It's going to cross the asymptote, and that is the only place it crosses. So what else that tells me is that over here, this comes up and it's going to hug the asymptote from underneath. On this side, when it goes up, when it crosses, it's not going to continue to increase exponentially like that, or not exponentially, but it's at negative infinity, it's going to be approaching 3. So even though it comes up over the asymptote right here, it comes back down, and if this was a little longer, then you would see that it just stays, it's approaching 3 from the top, where the right-hand side is approaching 3 from the bottom. Okay? We good with that? Any questions at all? All right, you can't be afraid of the algebra. That's something that you got to start getting more and more comfortable with, which means that it's not a race, but the more comfortable you are with it, the quicker it'll go, and the less you'll hate doing it every time it comes up. You won't even think about it anymore. It's just second nature. Okay? Any questions? You look like you have a question. Okay, just making sure. All right, good deal. Go ahead and tape that in the same way you did yesterday.